Hey, this is Math 6, Unit 2, Lesson 2, representing ratios with diagrams. Alright, so first of all, we had a little number talk. Dividing by 4 and multiplying by 1/4 is what it's called there. Okay, so just kind of little kind of review of what we call multiplying by the reciprocal, and that's a word you may be familiar with. Okay, and so if you have a number 4, the reciprocal is 1/4. It's sometimes we talk about flipping things over. It's not mathematically correct to say flip it over, but we talk about multiplying by the reciprocal. Okay, and so when we look over here, it says to find each value each expression mentally. Okay, so we have 24 divided by 4 first of all. So 24 divided by 4, if I know that 24 divided by 4, I made on my math facts hopefully, and recognize that that's going to be 6. No problem there. Now 24 times 1/4 is multiplying by the reciprocal of 4. So again, dividing by 4, if I set that up as a division problem, I could write it like this: 24 divided by 4. Over here, 24 times 1/4 is the same as writing 24 over 4. And since these two are the same thing, then my answer for 1/4 times 24 is 6. Over here, just a different order, 24 times 1/4 is also 24 over 4, so you still end up with 6. So these are actually 3 ways of writing the same exact thing, right? Same exact expression. Either multiplying dividing by 4 or multiplying by the reciprocal in both these cases here. 5 divided by 4 is a little bit different though, isn't it? Right? That can be written as 5 divided by 4. Just out of curiosity, what would the reciprocal of that be? The reciprocal of 5 over 4 would be 4 over 5. And one thing we just want to kind of keep in mind here is that whenever we take a number like 5 and we multiply it by the reciprocal, a whole number multiplied by a reciprocal, it has a value of 1. And that's because, again, if I look at it this way, I could write 5 as 5 over 1 and multiply it by 1 over 5. And when I go straight across, 5 times 1 is 5, and 1 times 5 is 5. And a number over the same number, any number over the same number, 5 over 5, has a value of 1. So this is something to keep in mind as a skill, to review skill from previous years. That's going to show up as we start talking about ratios and diagrams and playing with how those numbers relate to one another. Okay, let's move to activity number 2 for the day. It says here's a collection of snap cubes. Okay, we have here 1, 2, 3, 4, 5 yellow. We have 1, 2, 3, 4, 5 red. I see we have 3 pink, 1 black, 2 blue, and 2 green. It says choose 2 of the colors in the image and draw a diagram showing the number of snap cubes for these 2 colors. So let's go ahead. I'm going to go ahead and choose the red and the blue. All right. Noticing real quick, I have 5 red and I have 2 blue. So if I was to draw that as a quick picture here, and again, the sketches don't have to be perfect here, right? So I'm going to choose a little kind of a reddish color. I just have more like a pink, but it's what I got here. I'm going to do 5, 1, 2, 3, 4, 5 for the red one. And the blue, I'm going to make 2, 1, 2. And that becomes my little sketch there for the red and the blue snap cubes. Could I make them squares? Sure. Could I make them circles? Yep, it's just a diagram. Now trade papers with a partner, and on their paper, write a sentence to describe a ratio shown in their diagram. And your partner's going to do one for you. So I'm going to do one real quick based upon what I see right here. This is what I'm asking you to do with your partner, is basically say something like this. For every 5 red cubes, there are 2 blue cubes. Okay? So that's what we're going to be doing with one another's papers. So for you, you go ahead and select 2 colors of your own, draw a diagram, those snap cubes, and draw that picture like this, something along those lines. Trade papers with a partner, and then on your partner's paper, write a ratio to describe that there. Once you've done that, then you can trade your papers back and see what they wrote and see if you agree or disagree with what they wrote and explain your thinking. So if you're doing that in class together, then just push pause real quick and get going on that, and let's come back and pick it up in just a second. All right, activity number 3 today. It says Elena mixed 2 cups of white paint with 6 tablespoons of blue paint. Okay, so we have 2 whites for 6 blue, right? So we have 2 whites, 6 blue. Just making some notes here to help me remember my numbers. Here's a diagram that represents the situation. 2 to 6. I can think of it like this, 2 to 6. I can also, remember from our last activity, I can think about it being broken apart like this, and actually I have a group of 1 and 3, and repeat a group of 1 and 3. So different ways to view that diagram, okay? These are just my notes, okay? Discuss the statements that follow and circle all those that correctly describe the situation. Make sure you and your partner agree. So let's do this together. You ready? Let's see here. We have some different situations. Let's see what it comes up with. The ratio of white to blue is 2 to 6. Well, so they're saying that white to blue is 2 to 6. So the order matters here. They're saying white is 2 for every 6 blue. Is that a true statement? Here we have 2 whites for 6 blue. So that looks correct. We're going to say, okay, that sounds good. All right, the next one. For every cup of white, there are 2 tablespoons of blue. So that's going to be a cup of white and 2 blues. Well, does that match our pictures up here? What do we see? We see 1 white with 3 blues. So this is an incorrect number. That should be 3. So that's not a true statement. How about number 3? There is 1 cup of white paint for every 3 tablespoons of blue paint. So that's going to be 1 white, right? 1 white and 3 blue. 1, 2, 3. Does that match what we have up here? 1 white, 3 blue. It does, so that's going to be a true statement. There are 3 tablespoons of blue paint, 3 blue, for every cup of white paint. A cup is 1 cup of white. So they're saying, okay, 3 blue, 1 white. Now, yeah, it's flipped upside down than from the other one, but isn't it the same thing? 1, 2, 3 blue, 1 white? Sure it is, right? As long as your numbers are matching the words the right way, you're going to be all right. How about this one? For each tablespoon of blue paint, there's 3 cups of white. Okay, that would be 1 blue and 3 white. Is that what we see here? Nope, not going to happen. For every 6 tablespoons of blue paint, there are 2 cups of white. So 6 blue, 1, 2, 3, 4, 5, 6, and 2 white. That is a true statement there. And finally, the ratio of tablespoons of blue paint to white paint is 6 to 2. Okay, the order is important here. So the blue comes first, blue is 6, and the white comes second. So do we have 6 blue for every 2 white? 1, 2, 3, 4, 5, 6, and 2. That is correct. So yeah, they changed the order of the ratios around, or the number, or the word connections, but it's still the same, so it's okay. All right, let's look at the second one. It says Jada mixed 8 cups of flour with 2 pints of water to make paste for an art project. So flour has 8 and water has 2. Flour 8, water 2. Draw a diagram that represents this situation. Okay, so I can draw flour, 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 flour. It's 4, 5, 6, 7, 8 flowers, for water being 1 and 2. Okay, and I can make little circles for each one if I wanted to, or squares, whatever you like there. Okay, so I have 8 flowers for 2 waters. Write at least 2 sentences describing the ratio of flour and water. Okay, so I could say there are 8 cups of flour for every 2 pints of water. That works. What else could I do? I could recognize that I could split it down the middle there, and they're even groups there. I actually can do a 4 and a 1, right? For every 1 pint of water, there are 4 cups of flour. So for every 1 pint of water, there's 4 cups of flour. That works as well. And there are many others that you can write there. That's up to you to write them out, but there's a couple examples again. This is just review from today's lesson anyways. Okay, let's move to the next activity. For the next activity, your teacher gives you, or is going to give you, some cards describing different recipes for spaghetti sauce. So, in the diagrams that you have, a square represents tomato sauce. That's tomato sauce. Should read my own directions. A circle represents tomato sauce. A square represents the oil. And a triangle is the oregano. Okay, those are my 3 shapes I'm dealing with here. So you might have a shape that looks something like this. Here's a card here. And what we see in this card, diagram A, is we can see that I have 2 squares, so it's oil. So the oil is 2. And for the circles, the circle is the tomato sauce. Tomato sauce has 1, 2, 3, 4, 5, 6 tomato sauce. So if I was going to find a statement that matches that, which is our idea here, your teachers give you a bunch of sentences, I need to find a sentence that explains and describes this ratio right there. They might say something like, for every 2 tablespoons, this is tablespoons, this is cup, for every 2 tablespoons of oil, there are 6 cups of tomato sauce. It could say for every 6 cups of tomato sauce, there are 2 tablespoons of oil. It could also recognize that that can be split down the middle there and say for every 1 tablespoon of oil, there are 3 cups of tomato sauce, 1 to 3, and vice versa. So for this one right here, the actual card that'll go with this one, if you have done this already, just to review, is this sentence right here that says, there are 3 cups of tomato sauce for every tablespoon of oil. So in actuality, what do? They did split it this way and made some smaller groups to show that we have 3 to 1 when it comes to that ratio describing the oil and tomato sauce there. Okay? So what you're going to do with your partner is you're going to take the rest of the diagrams that exist, and you want to take those diagrams and you're going to try to match them with the sentences that you have. So be careful with them. Make sure you're remembering which ones are going to be the sauce, the oil, and the oregano, and see if you can figure those things out there on your own. Okay? So that's your activity. So you're going to work those out. I'm going to let you do that there. I'm not going to do that. I'm going to go ahead and just kind of lay them out here for you so you can see what they are in case you weren't sure. And so if you're working at home and trying to catch up, maybe look at a couple of these and you decide what ratio could you use to describe the different cards that you see right there, just like we did for letter A, right? So there's B, C, D, E, and F, not in any great order. So what could you do to describe those there? Okay, so that's what the cards look like. And they have a lot of sentences that go with them. And some of the sentences can work for a couple, that's okay. But work on those with your partners there. I'll put A back on there just so you can see it as well. And those are the 6 you're working with there. Okay, so that's that. If you're just kind of in class, you can kind of pause that there and take a look at them and write some sentences that go with A, B, C, D, E, and F. Okay, I'm going to take them away. Moving away, moving away, moving away, moving away. And let's take a look at number 2. Says to talk about any errors you saw. That's something you can talk about there. What are things you agreed on, disagreed on? Okay, and discuss and maybe change how things match up if you need to. And finally, 3, there were 2 diagrams that each matched 2 different sentences. Which were they? Okay, so what we saw was that diagram B, find B here for you real quick. B, where did B go? Nope, that's F. I'm going to find them all but B. It'll be the last one, I'm sure. Yep, there it is. Diagram B actually matched with a couple different sentences. It matched with sentence number 2, which I can't find right now. There it is, there 2. And it matched with sentence number 8. Alright, so when we look at sentence 2 and 8 and compare the 2 together, we have the oil and the tomato sauce, and we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 oils and 3 tomato sauce. So first it said that there are 3 tablespoons of oil for every cup of tomato sauce. So what are we doing in this one? We are separating into groups like this and like that and doing a 3-to-1 ratio there. Perfect. When we look at sentence 8, it says the ratio of cups of tomato sauce to tablespoons of oil is 1-to-3. So it's going 1-to-3. So it just depends on which way you read it. In sentence 8, we're going this way. In sentence 2, we're going this way. But we're describing the same exact diagram just from a different perspective. Okay? So for diagram B, it matched sentences 2 and 8. And another one that was like that was diagram E, which happened to also match sentences 3 and 7. Okay? So number 4, select one of the other diagrams and invent another sentence that could describe the ratio shown. I'm going to let you do that on your own. Alright, so as a summary of today's lesson, ratios can be represented using diagrams. The diagrams do not need to include realistic details. For example, the recipe for lemonade says mix 2 scoops of lemonade powder, 6 cups of water. So instead of doing all these scoops and cups and being detailed about what a cup looks like, you can just draw some squares or circles and say, those are my scoops of lemonade, and here are my 6 cups of water, right? There's my 2, there's my 6, and I'm set to go. Okay? We also can look and see that we can take these here, and we can see that for every 1 scoop of lemonade, there are actually 3 cups of water. And so we can recognize that I can have smaller ratios inside of the larger ratio as well. Okay, so that's it for today's lesson. Let's take a moment to pause, work on our homework, and we'll come back together to check that in just a couple minutes. Okay, so here we go, homework for lesson 2. Here's a diagram that describes the cups of green and white paint in a mixture. We can see we have 4 green for every 2 white. Awesome. I can also see that if I was to group this here into smaller sections, I could also say that there are 2 green for 1 white. Alright, same idea, no problem, different ways of looking at it. Select all the statements that accurately describe the diagram. Okay, let's be careful of the order of words here, right? The ratio of cups of white to green is 2-to-4. So white to green. Now white is 2, green is 4, so 2-to-4 is the correct wording and order. That is fine. B, for every cup of green, there are 2 cups of white. So green is right here, right? So every cup. So 1 green becomes 2 white. Do we see that anywhere? Do we see, nope, we actually see what? We see 2 green and 1 white. So in this case, they got the numbers or the colors switched. So that is incorrect, and that's what you have to be careful about. C, the ratio of cups of green to white is 4-to-2. So they're saying 4 green, 2 white. Keep that order there. Don't worry about the picture. Look here first. 4 green, 2 white. Does that match? 4 green, 2 white. Yes. D, for every cup of white, so 1 white, there are 2 cups of green. 2 green. 1 white, 2 green. Let's take a look here. I go here. 1 white, 2 green. True statement. The ratio of cups of green to white is 2-to-4. So 2-4, so 2 green, 4 white. Do we see that? Here are 2 green, they go to 1 white, not 4, so that would not be a true statement. Okay, so make some notes as you do this just to make sure and not be in a hurry and say, oh, I read it. If you read it too quickly, you might make a little error, so attend to precision there when you're reading, okay? Be very cautious. Number 2. To make a snack mix, combine 2 cups of raisins, 4 cups of pretzels, and 6 cups of almonds. Create a diagram to represent the quantities of each ingredient in this recipe. Alright, so let's go with, first of all, we have raisins. So we'll have a raisin and a raisin. Delicious. 4 cups of pretzels. So we'll go pretzel, 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 pretzel. And 6 cups of almonds. Almond, 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 almond. Okay, so make sure we got these right here. We have 2, we have 4, and we have 6. Use your diagram to complete each sentence. The ratio of blank to blank to blank is number, number, number. Okay, so the ratio of raisins to pretzels to almonds is 2 to 4 to 6. Could you do that differently? Absolutely. You could change the order around, but as long as you change them to match, right? Make sure your words match the order of your numbers and vice versa. Okay, there are how many cups of pretzels for every cup of raisins? Okay, so a cup of raisins is 1. So for 1 cup of raisins, how many pretzels are there? That's the question here. So noticing that we're going to look at 1 cup of raisin, I want to probably see if I can split this evenly down the middle. If I split it there, are they the same? 1, 1, 2, 2, 3, 3. Yep, we're okay. So another ratio here could be 1 to 2 to 3 if I looked at just a smaller group. So for 1 cup of raisins, how many pretzels? We're going to go with 2 pretzels. Here we have cups of almonds for every cup of raisins. Again, cup of raisins is 1. So how many almonds? If we're doing 1 raisin becomes 3 almonds. Alright, so just be careful that the order and reducing, this is a great little question there. Number 3. A square is 3 inches by 3 inches. What's the area? So area is 3 inches times 3 inches, which equals 9 inches squared. B. A square has a side length of 5 feet. What's the area? 5 inches times 5 inches, length times width, becomes 25 inches squared. No problem there. And then finally, the area for number 3C. The area of a square is 36 square centimeters. What's the length of each side? So we're asking what number times itself, because it's a square, can equal 36 centimeters squared. So in this case here, we would say, knowing our math facts, 6 times 6 equals 36. So the length would actually be 6 centimeters. Number 4, a review from Unit 1. Couple ways of doing this one. Okay, I could first of all cut this in half like that and say I have 2 triangles. I could find the area of the first triangle and add it to the area of the second triangle. That's one way of doing it. I could also recognize that if I cut this triangle here, I could rotate that one around and draw a nice square like this, right, by flipping that over there. And I could do the same thing on this one by rotating that one over there. And in doing that, what I have is a large rectangle which has a height or base of 3 and a height of 1, 2, 3, 4, 5, 6, 7, 8 for an area of 24 units squared. That's kind of the short way of doing it. Could have done it a different way? Sure, I could have taken the triangle. This first one has a base of 1, 2, 3, 4, 5, 6. So 1/2 of 6 times the height of 1, 2, 3. Half of 6 is 3 times 3 is 9. And then done the bottom one, which is 1/2 of the base, which is 6, times the height, which is 1, 2, 3, 4, 5. Right? And half of 6 is 3. 3 times 5 is 15. And combine those to say 9 plus 15 is 24 units squared. So you might have done it with 2 triangles, or you might have decomposed that and rearranged it and got with 24 to make a giant rectangle. Depends on what you see first. Sometimes it's a little faster some ways than others. And the last one here, complete each equation. This came from our warm-up from today. So 8 times its reciprocal becomes 8 over 8, which is the same as 1. Okay? And here we have 3/8 times 8. I could think of this as going straight across, and so I end up with either 24. I could think of it as 24 over 8, or 24 divided by 8, or I could recognize like reduce there, and I end up with 24 divided by 8 is just 3. This one, straight across, 7 times 1 is 7, and 8 times 1 is 8, and it's just 7/8. And finally over here, this is 3 times 7 is 21, and 8 times 1 is 8, and I can leave it there, or I could turn it into a mixed number as well. Alright, that's it for today. Have a great one, and we'll see you next time.